Hey everyone, welcome to Conquering Algebra 2, Lesson 34. In this, we're still going to be talking about uniform motion problems. The difference here is that their distances won't necessarily be equal. I like to call these types of problems head start problems. So here is an example of what the diagram may look like, and your story problem may be something along the lines of the first person had however many miles head start. They started at the same time. How long until the second person caught up to them? And so that's where this K comes in. So to write this as an equation, we would say R1 T1 plus K equals R2 T2. So their distance plus whatever that head start was is going to equal the second person's distance. So let's look at some examples. Okay, so here's our first practice. Millicent began her journey at 6 a.m. at 50 kilometers per hour. So right there, we already know that the rate of Millicent, so Rn is going to be 50. We also know that Bo started to chase her at 60 kilometers per hour. So the rate of Bo is 60. At what time was Bo within 40 kilometers? So that's our gap that we were talking about. So Millicent is going to go this far, and then this is Bo, and our gap is 40. So we got the rate of Bo, time of Bo, and then we have the rate of Millicent, time of Millicent. So that's going to be our master equation. Okay, so there's that, and we have two equations about rate. We have 3 equations total. We should have 4. We haven't done anything about time yet. And they don't tell us specifically what time either one of them was done. They want us to tell them at what time was Bo within 40 kilometers. But we do know something about Millicent's head start. She starts out at 6 a.m. and Bo chases her at 10 a.m. So she has a 4-hour head start. So whatever the time of Bo is going to be the time of Millicent minus 4. Or you could say the time of Millicent is the time of Bo's plus 4. Either one is fine. It doesn't really matter. And so now we're in a place where we can take this, plug it in here, and solve. Okay, so the rate of Millicent was 50. We don't know time of Millicent. That's our unknown. And then the rate of Bo is 60. Time of Bo is Tm minus 4 plus 40. Our next step is we're going to distribute the 60 Tm. So 50 T of m equals 60 T of m minus 240 plus 40. And we can add these like terms. So that's going to be negative 200. And subtract 60 T of m, both sides. So that's gone, and we're left with negative 10 T of m. Divide both sides by negative 10. All right, and when we do that, T of m will equal, going to knock out a 0, make those positive. It's going to equal 20. So the time of Millicent was 20 hours. So 20 hours is 4 hours short of a full day. If this was 24, then we would know it would be 6 a.m. the next day. But because it's 4 hours short, we can just subtract 4 hours from 6 a.m. And we know that Bo is within 40 kilometers at 2 a.m. And that's it. That's what they were looking for. They didn't want to know distance. They didn't want to know all the hours for both parts. They just want to know at what time would Bo be within 40 kilometers. So we're done. Our second example is going to be the other type of scenario that we'll see with this particular type of word problem. In this case, Robin Hood is going to have a 7-mile head start. So when the sheriff began his pursuit, Robin Hood was already 7 miles out of Nottingham. If the sheriff traveled at 6 miles per hour while Robin Hood's rate was 2.5 miles per hour, how long did it take for him to catch up? So with our diagram, Robin Hood has a little bit of a head start. So this would be the rate of Robin Hood, time of Robin Hood, and then the rate of the sheriff, time of the sheriff, and how long until he catches up, which means their endpoint is the same. And it also, in this case, it means their time is the same. because it would be like with you and a younger sibling, how you give them a head start. You still say, okay, ready, set, go. You still start at the same time. You still end at the same time. But there is that head start gap right here. So we know that the time of Robin Hood is going to be equal to the time of the sheriff. We also know that the rate of the sheriff was 6 miles per hour and the rate of Robin was 2.5. I'm going to make that a decimal rather than a fraction. Just dealing with all of this distributing, it's going to be easier if it's in decimal form. So we have 3 equations to substitute. We also know our master equation because of this, so we're pretty much ready to go. So we have the rate of Robin, time of Robin, plus his head start of 7 equals the rate of the sheriff, time of the sheriff. This is going to be our key equation, our master equation that we're going to plug everything else into. And so now we can just start plugging it. So the rate of Robin was 2.5. And we're going to stick with the time of Robin plus 7 equals the rate of the sheriff was 6. And instead of time of sheriff, I'm going to replace it with the time of Robin Hood because they're equal to each other. And I had to make sure I only have one type of variable in order to solve. And now we just get the time, we get T of R by itself. So minus 2.5 TR. So that is gone, and we're left with 7 equals 3.5 time of Robin divided by 3.5. So that's gone, and the time of Robin Hood was 2 hours, which will also be the time of the sheriff. And the question that they're asking is, how long did it take to catch up? And so the answer is 2 hours. That's it. All right, and that's it for lesson 34, talking about uniform motion when they don't have equal distance necessarily. There's either a head start or a gap of some sort. So I hope this was really helpful. If you guys have any questions, leave them in the comments below. I'd love to help out wherever I can. And to my Algebra 2 students, I'll see you guys in class.